Welcome back to another tutorial. So in today's tutorial, we are going to implement the ranged monsters. So last tutorial we did the melee monsters which run up to you, start attacking you. This time we're going to do the melee monsters, and because I'm not quite sure how to implement the AI for moving away from the player, I decided rather than having them move around and shoot, we just create a static enemy that just stands there and keeps shooting at you. It will allow us to do a bit more tweaking as far as having the melee monsters run to the player and then having the monsters shoot at the player, so that the player would kind of have to run away from the melee monsters whilst focusing on the ranged monsters. So as per usual, we'll start off by creating a new class called ranged monster.hx. Okay, so we'll say class ranged monster extends HaxeFlixel sprite, and then new, yes, have to, no, get imported. I don't know why new doesn't want to, there we go, x float, y float, and then super xy. Awesome. Now the ranged monster would be a bit more different than the melee monsters, since we don't really care about movement speed, we don't care about the damage per second, because all the damage would be done by the projectile, and that would thus be handled by the projectile. So the variables that we will have for this class is, we'll start off with the armor of .float, private var target of type FLX object. Still as horrible as typing as I have ever been. We want the projectile type. Private var. When was the last time the shot was fired? So last shot of that float. And then private var shot variable of type float. So the shot variable is how often we want the monster to shoot, and the last time that the monster last shot is a variable that like will increment, and then if last shot equals or is greater than the shot variable, then we want the monster to fire a shot. And then when it fires a shot, we want to set last shot to 0 again, so that it increments again up to the shot variable. Okay, so in the constructor, we want the target of type FLX object, and we want the projectile type of type projectile type. So for now, we'll set the armor to 0, although we can implement a bit more buffed armored version of the ranged enemy for harder levels. Say like during the boss fight, we would spawn like 5 or 6 armored ranged units to keep firing whilst we try and like dodge the boss and things like that. And then we want the target equals target. We want the projectile type equals projectile type. And the last shot equals 0. And then the shot variable for now will create a random random dot float, or let's start with integer, of 0 and 5. Now I'm well aware that we created the shot variable to be a float, although because this is the programming language allows us to dynamically cast variable types. So even though it's an integer, when it runs, it'll be handled like it would be a float. So it will still work and everything. Although next tutorial we can change that. I just want to show you something really cool for now. And also remember, this is inclusive, so it's between 0 and 4, I think. No, 0 to 5, because both are inclusive. So it's between 0 and 5. Now we want to make the graphic 20 by 20, and that was a fail. So 20 by 20, and then FLX color dot, let's go with the cyan color, because we already used blue, and in my notes I used blue, but I remembered from when we did the projectiles that the ice projectile is blue as well. Now, to follow good object-oriented standards, we want to say function get target of type FLX object, return target, we also want the get projectile type, public function get projectile type, return projectile type. And I just want to be a bit more specified of what we are returning. Projectile type. Oh yeah, and then semicolon, don't forget that. And now we want a function to check as to whether or not we want the enemy to fire. So we would say, so in my notes, I did this a bit different. I used a function that takes an elapsed time, although it might just be a bit better to create a function for it. So if we say something like private var put fire of type bool, and we say put fire equals false, then we can go into the update function, override update, and now here we can say, so last shot plus equals elapsed. So the elapsed variable is the amount of time between each frame. It allows us to implement logic into our game that is not GPU bound. So even if your computer like really beefy, top of the range graphics card, top of the range CPU, and you can get up to like 10,000 frames per second. Imagine if our movement speed was capped to frames per second rather than elapsed time. You would press like your right button and your player would move 1,000+ units in one go, because it's not capped to the elapsed time, it's capped to frames per second. So frames per second just allows us to have this a bit more realistically between all variable kinds of computers, depending on whether they're strong or weak, they will have the same movement speed. So if last shot is greater or equal to shot variable, so last shot equals 0. Return, and we don't want to return something. We just want to say that the should fire equals to true. Then else should fire equals false. So if we set should fire to true, it will always be true whether or not we change it. So if we don't change it, it will just stay true, and you'll have your unit create new projectiles at each frame. Whereas, so this, if it's back to 0, it's less than and not equal to, so we set it back to false for the next frame then. And then we just want a getter, so public function get should fire of type bool, and then return should fire. Awesome, that's a bit more object orientated, and I think I like this a bit more than what I did with my notes. So now that we have everything set up in our ranged monster, we can go over to play state. To see if we can test it and everything works. So ranged monster, copy. Yeah, it's going to complain. Let me just open my notes. So we want to add a new ranged monster, add standard int standard random. I don't know what my brain did just there. So 1000, and we can just copy that. And then next is the target, so player, and then the projectile type. Just to test, we'll create firebolt because it's nice and red and it stands out against everything else. And then now we want to loop over each of the monsters, but to do that we want to go in and create a function that will handle the looping. So function should handle monster, and it requires a monster of type ranged monster, and it returns type void. So if monster dot get should fire, we want to instantiate a new projectile of type projectile at the monster's X and Y positions, and we want the target to be monster dot get target dot get position. So the position of the monster, and then we just go with monster dot get projectile type. So this is one of the reasons why that's very useful with setting up getters and setters, is you can just use a function get the position, and it's verbose. It says that you are getting the position. You're not getting a reference that's changeable. You're literally just getting the value of it. And then add a new projectile. Awesome. I think that should work. Well, let's test it. Let's see if I can code on the run. Hopefully my game doesn't just like blow up laptop burst into flames type deal. That would have been really bad. Yeah, wait for it. What could have gone wrong? Every frame it updates. I swear I do this every video. Like, this is the third video in a row that I've done this. I'm such an idiot. Okay. So, monsters got 4 each. And then handle monster fire. Awesome. And now this should work. So this function will handle the should fire function for every monster in our Flixel typed group, and it will check if it should fire or not. That works a lot better. And this is the thing that I wanted to show you. It looks like tentacles almost, and I posted a video of this on Twitter like last week where I showed off me finding this. Now, something you will notice, it's absolutely horrible for my frame rate, and my computer's probably going to, you can see it's like down to 20 frames per second, because what's happening is it has to keep track of every projectile that we instantiated into memory, and I'm not sure if they do culling to see if it's like out of range or outside the camera, it like gets cut off or not, but it's trying to keep track of its position and things like that, which is horrible, and you should never do that. In the next tutorial, we'll handle on how to make it a bit more memory safe and a bit more usable on our computers. Now, you'll have to wait until next week to get to that, but in the meantime, please drop a like, subscribe, and drop a comment of how much you enjoy this video. Also, I have my Twitter link will be down in the description below. Thank you for watching. Enjoy your week.